This presentation is on the hyperbola. A hyperbola is a collection of all points in a plane, the difference of whose distances from two fixed points, called the foci, is constant. This is the same definition as the ellipse, except we have the difference is always constant instead of the sum. The hyperbola has two symmetric parts called branches. Each branch has a vertex and a focus. The axis that contains the vertices is called the transverse axis. Center, transverse axis, and the conjugate axis. The foci there, and there are vertices, which are all of these are all on the transverse axis. And the black dashes are asymptotes for the graphs. The equation for hyperbola can be derived by using the definition and the distance formula. The equation is here, x squared divided by a squared minus y squared divided by b squared equal to 1, where b squared is equal to c squared minus a squared. This looks similar to the ellipse equation, but notice the sign difference. Now, to graph a hyperbola, make a rectangle that measures 2a by 2b around the center as a sketching aid to draw the diagonals. They are the asymptotes. We have 2a and 2b across the diagonals are where the asymptotes would be. And our C here, which is also on that transverse axis, is going to be B. So here we can have, since a squared is larger, not larger in this case, since x is positive, it's spread out. Since x is positive, it's going to spread out over the x-axis here. So you can see that. So we have a center. Since x is positive, it's going to spread out over the x-axis there. In this case, 3 squared is 9, so a is 3. Ends of the transverse axis are the vertices. See the vertices here and here. And the vertices are also points on the hyperbola. From here, the center is the b direction. So square root of 4 is 2. So up, down, 2. So we can draw a rectangle now and draw the diagonals for the asymptotes. There's the asymptotes there. And we know where the vertices is. We can find the foci. There are C away from the center along that transverse axis. So it should be in here somewhere. C squared is 9 plus 4, square root of 13. There and there for our foci. now we can go ahead and just sketch it out. There's a sketch of a hyperbola. Let's find the equations of the asymptotes. So remember, the slope is what? The change in y divided by the change in x. So we have here what? 2 units divided by 3 units, the change in y. In the form of y equal to mx plus b. Since it go through, b is 0 since it goes through the origin. Y is equal to mx. What is the slope? Rise over run. We have 2/3. Okay, the second line has the same slope, only negative. The equations of the asymptotes will be a plus or minus 2/3. The center of the hyperbola may be transformed from the origin. The equation would look like this. Notice the x squared is positive. We have here a horizontal transverse axis. In this case here, notice the y squared is positive. For vertical transverse axis. The axis is determined by the first term, not by which denominator is largest. If the x term is positive, it will be horizontal. If the y term is positive, it will be vertical. The axis is determined by the first term, not by which denominator is largest. If the x term is positive, it will be horizontal, spread out along the x-axis. The y term is positive, it will be vertical, spread out along the vertical axis. In this particular problem, they want us to find the center, the foci, vertices, and graph of the ellipse. So we have to complete the square here. We have to collect our y and x terms, get a constant to the other side. Okay, so in order to complete the square, the leading coefficient for the squared term must be 1, so we factor out a 4 and a 3 respectively before we can complete the square. So what number do we have to add? We have to take half of the y term here and square it. Half of 2 is 1. 1 squared is 1. So for the x, half of negative 2 is negative 1. Negative 1 squared is 1. Then we have to add the same things to both sides. Notice it's times 4, and that's times a negative 3. We complete it that way. We put it into a factored form. That's what it looks like. But in order for it to be in standard form, we have the right hand has to be equal to 1, so we divide through by 12. And there's our equation in standard form. In this form, we can go ahead and extract the info we need to and graph it in the next screen. Here we can see what the center is going to be. Negative 1, 1. That on the y here is negative 1 and the x is 1. And there you have it. The x is 1 and the y is negative 1. Okay, in this case here, y is positive. So it's going to be spread out over the y-axis, and a squared. A squared is 3, so a is equal to the square root of 3. That'll be the major axis there. Okay. So spread out along the y, we can go up the square root of 3 and down the square root of 3. Along the y, going up the square root of 3 and down the square root of 3 for the vertices. So b squared is 4, so b is 2. So start from the center, we can count over 2 and to the left and to the right. Okay, so we have those little 4 points there. We can make a rectangle and draw asymptotes. So we do that. And it gives us an area, since we know it's going to be spread out over the y-axis. All right, we have our vertices there. On the foci, c squared is equal to a squared plus b squared. So 3 plus 4 is 7. C is equal to square root of 7 or 2.6, and that gives us the foci. Starting from the center, count up. So you can count up from there. We have our so we have our asymptotes, we have our vertices. We can basically sketch a graph now. And there's our sketch of the hyperbola. Okay. And that is the end of the slideshow. Have a great day.